Welcome to chapter 14.8, Pure 1, which is the last lesson about logarithms, in which actually also one of the most important chapter in the logarithm chapter, because you're going to apply all the knowledge you have learned about logarithms, exponential, natural log, ln, into modeling question. And we know how much the exam board love about modeling. It's crazy that they put so much love into modeling, which is absurdly exponential. Anyway, or exponentially absurd. Well, English too difficult. We do maths, not English. So now here we go. We'll start at question one first. Okay, see if you can get the same answers I do. Okay, so pause video, have a go at start at question one first. When you're ready for the answer, you can press play. So what we're going to do is I'm going to write y equals ax to the power of n, and then I'm going to take log on both sides. So I'm going to take log on both sides, becomes log ax to the power of n. Now the left hand side is log y. Now, but the right hand side, we can apply log laws, the multiplication law, log ab, which equals to log a plus log b. And then power law, so log y equals to log a plus n log x. So that gives you the answer. Okay, so I want to bring in this format. Now you might be wondering why. Okay, these two started question provide you the very essential algebraic manipulation when it comes to modeling question, which we'll see this skill quite often. Anyway, so if you're happy with this, try to apply the same thing for starter question number 2. Okay, pause video, have a go. When you're ready for the answer, you can press play. Here's the answer. Okay, so log y equals log a plus x log b. Okay, right. So notes, sometimes, okay, when plotting raw data collected in scientific experiments, maybe in here we talk about number of, what do you say? Translators, increase exponentially. You can see it's an exponential graph, e to the power of x graph. They do not make a neat graph, and sometimes it's not nice to present, the graph like this, where because it's harder to do any scientific research or any calculation on exponential graph, or at times rather useless. But by logging the data, a better straight line graph can be formed. So you can see this is a straight line, which is much easier to interpret because if we talk about, maybe think about correlation, think about predicting the future, it's probably much easier using a straight line rather than exponential graph, right? So let's look at the next one. So example in here, okay, the table below gives the rank by size and the population of UK's largest cities and districts. So London obviously ranked number 1, but it's been excluded because outlier. So if you compare population with London, that's actually a lot more than Birmingham, second and third place. I can't remember the population of London. If you know, do let me know. But actually, I can't remember. I should know, but I don't. Anyway, so Birmingham, Leeds, Glasgow, Sheffield, Bradford. Here's a ranking 2, 3, 4, 5, 6, and the population has been 1,730,000, etc. Okay, here's a question. By the way, if you want this square paper, you can download a PDF on my website and then go to resources. You'll find this document on chapter 14 notes, pure 1. Right, so the relationship between the rank and the population can be modeled by the formula R equals AP to the power of n. Draw a table giving values of log R and log P to 2 decimal places. So let's do that. Okay, so what we're going to do is we're going to draw a table. Okay, very simply, we have log R and log P. Okay, so what you want to do is if you log 2, okay, so R log 2, put in calculator log 2, you should get 0.30. And then if you push log 3, okay, actually I should put Birmingham, I should put the Birmingham, and then Leeds, and then Glasgow, Sheffield, and then Bradford. Okay, so what I'll do in here as well is I do Leeds, so log 3, put in log 3, you should get 0.48. Glasgow log 4, you should get 0.6. 0.7 for Sheffield. Bradford, you should get 0.78. Okay, for log P, log a million, you should get 6. And then here you should get 5.86. That's part A, by the way. And then log 622,000 is 5.79, 5.72, and 5.68. Okay, by the way, this is will be the X column, X row, and the Y row. Okay, so log R is X and log Y is a Y. Log P is a Y. So we've done part A to two different places. Part B, plot a graph of log R against log P. So now that's a mistake in here by the question. It should be log. When you say log R against log P, the first value is usually the Y. So I believe the question should say log P against log R, But anyway, the graph is given to you. So you know log P is on the Y, log R is on the X. And use the values from a table and draw the line of best fit. So what we can do here is, can we make, so from the X, we can see we go from 0.3 to 0.78. Can we do 0.1 every two squares, 0.1, 0.2, 0.3? I'm going to do every two squares as 0.1. And for the Y, I'm going to do this little symbol here. And then we can start from 5.6, 5.7, so etc. So I'm going to prepare the graph. Right, so here's a graph. In exam, normally they don't give you, they won't ask you to plot the graph. They'll give you the graph. Okay, but anyway, we're gonna do it from the scratch. So we've got log R. So the first value is 0.3 and 6. So 0.3 and 6 is here. Next point, 0.4 and 5.86. So just roughly, 0.4 is here, and 5.86 is somewhere here. That's 85, so 86 will be here. Okay, and then you plot all the same to 0.6 and 5.79, maybe somewhere here. And if you plot the rest of the 2 points, they should be here. So you've got the points. Okay, so what the question wants us to do is the question wants us to draw a line of best fit. So let's draw a line of best fit. I think that's a really good line of best fit. Okay, right. Use your graph to estimate the values of A and N to two significant figures. So what we can do here is if we try to extend a line, we'll find the values A and B. So what's value A and B? Okay, so now what we'll do is let me try to extend the line. Okay, so use your ruler, just try to extend the line. Okay. Right, so what I want to do in here is to find the values A and N. You can see that A and N value are from R equals AP to the power of N. So R equals, that's part C, AP to the power of N. But the graph is given as log P and log R. So what we want to do first of all is we want to transform this equation to the log form. What does that mean? That means we want to do something similar to the starter question we did. Okay, so imagine that we've got R equals AP to the power of N. We want to make it log R. So we'll do the same. So let's try log on both sides. So we'll go log on both sides to begin with. So log R equals to, using product rule, log A plus log P to the power of N, which equals to log A plus N log P. Now you might be thinking, how does it help us? How does it help us to work out value of A and N? Now, if you notice, this is a straight line, right? A straight line has a form y equals mx plus c. Okay, so that means if I want to use this graph, I must be recognizing this must be the y equals mx plus c form. So I want to compare this with, so I'm going to compare, okay, oops, I want to use a different color. Okay, so I want to compare using y equals mx plus c. So where's your y? Well, if you look at this, log p is my y, right? So log p is my y. So what I want to do is I want to make log p the subject. So we realize log p is the y value. So what do we need to do? Well, let's make this. So that's your y. If that's my y, I'm going to make y the subject. So I'm going to make y the subject by minus log a on the left hand side. So log r minus log A equals n log P. Now and then what I'll do is to make y the subject, I want to divide by, make log P a subject, divide by n across. So it'll be 1 over n log R minus 1 over n log A equals log P. Now, let's bring log P to left hand side. Rewrite it, make log P left hand side. So 1 over n log R minus 1 over n log A. Well, what does that mean? Now, let's have a look again. That's your y. Log R is the x. That's your x. Therefore, this has to be an m. And this has to be a plus c. So from there, what we can do is we understand two things. 1 over n log R is the gradient, equals the gradient. And negative 1 over n log A equals, actually 1 over, not log R, it's just 1 over n, sorry. 1 over n is a gradient, 1 over n is a gradient. Right? Minus 1 over n log A equals the y-intercept. So we can use the graph, okay? Next, we can use the graph. So let's use the graph. So what can we do? Okay, next, I'm thinking how can I structure it better? Okay, so from graph, okay, so from the graph. So what's the gradient? Well, we can find a gradient using this table values that we found in here, right? So we can find a gradient by doing difference in y over difference in x. So 5.86 minus 6. So 5.86 minus 6 over 0.48 minus 0.3. Now, if you struggle to understand where this comes from, use a pencil. You can make a link from this table value all the way to here. So 5.86. So 5.86 minus 6 over 0.48 minus 0.3, which is negative 7 over 9. Well, then from the calculation, we now know, or also we have to find out y-intercept. So from the y-intercept, let's use the graph. So if we use the y-intercept, if you're doing here, that's 6, 6.1, 6.2, 6.3-ish. So let's do 6 point. So that's 6.3. Okay, so from the y-intercept, from the graph, we know y-intercept is 6.3. So what do we know? What it means is we know 1 over n equals a gradient, negative 7 over 9. Also, minus 1 over n log A equals 6.3. So let's carry on with the calculation. Okay, so 1 over n equals negative 7 over 9. That means n equals to 9 over minus 7, which if I put in a calculator is negative 1.29. Therefore, for the second equation, if I sub in negative 1 over negative 1.29, log A equals 6.3. Cancel the negative times the 1.29 to the right hand side. Log A equals 6.3 times 1.29. So let me do 6.3 times 1.29. That's 8.127. So log A equals 8.127. Therefore, A equals to, remember, as a base 10, log AB equals C, C equals A to the power of B, using base law. And you should get roughly around, so if you put in a calculator, it's a very big number. It should roughly equals to 134. I'll go around it. So let me write the whole thing. So which equals to 133967669. So that's roughly equals to 134000000. So that's the value of A and N. Now, very confusing, isn't it, with modeling question? All right. Oh, the question wants two significant figures. Okay, two significant figures. So let me change the answer into 130. Okay. And actually that equals to 1.3, negative 1.3. Okay. Right. Anyway, so sounds very confusing, isn't it? Well, think of it. Okay. So if you're struggling with this question, okay, now pi is just doing a table of values. Okay. Pi and part B is not really usually examinable, but part C is more examinable. So part A, imagine they give you a table, and part B, they give you the graph. Okay. So what you need to do is from the graph, you need to find the y-intercept and the gradient because it's a straight line. So if I want to use the graph, I need to convert my variables R and P into something into relatable to the graph, which is log P and log R. So from there, I can get a hint where I have to log on both sides in order to get a log somewhere. So log on both sides. Okay. Once I get there, I look at my axes. Log P is on the Y and log R is on the X. Therefore, I have to make log P the subject. Now, these little notes, do write some notes down there, what we're trying to do in here. Essentially, step by step in here, I'm going to log on both sides, and I'm going to make here, I'm going to make log P a subject. Once I make a log P a subject, I quickly realize that's my Y, that's my X. So if I think about Y equals mx plus C, that would be my M, and that's my C. So M is 1 over n, and C is negative 1 over n log A. In other words, then I need from the graph, I can find a gradient using the value table values and the graph. I know the gradient is negative 7 over 9 and the y-intercept is 6.3. Sometimes these two values are given to you rather than you interpreting from the graph. So anyway, we've got these two numbers, then we have to put it back into our equation. So 1 over n is a gradient, so I equate them and find n, and then equate the negative 1 over n log A to the y-intercept, and then just solve the equation from there. Okay, so let's look at, okay, so your turn. Let's have a go at this one. Okay, Kleber's law is an empirical law in biology. Okay, so you've got the M and R in here. Okay, so I've got table values. Okay, part A, draw table values. Okay, giving values of log M and log R correct to two decimal places, and plot a graph of log R gives log M. So I would say, okay, use a pencil for part A and part B. Okay, have a go. Part A, part B first. Okay, when you're ready for the answer, you can press play. Right, here's my final answer for part A. On top right, there's you see a table. Okay, part B, you see this. Now, for part C and part D, it depends on how you draw a graph. You might have a slightly different answer, but that's perfectly fine. In the real exam, usually they won't ask you sketch graph, so don't worry about too much. If you're struggling with scale, what I did was every 5 square was 1 on the x, and on the y-axis, I do every 3 squares is 1. Okay, again, it's not a big deal where we don't do it, perfectly on scale. Yeah, so you can see this really applies into sort of like scientific data, which sometimes numbers do not line up really perfectly. So I guess, as that, don't worry about too much about scale. You will see later in exam question where usually the gradient and the y-intercept will be given to you rather than you sketching out and finding it yourself, because it was such a waste of time to assess these kind of useless skill in pure maths. Pure maths, not science. It'll be useful skill in science, but not for maths. Anyway, have a look. Okay, have a go at part C. Part C. Okay, use a graph to estimate the values A and B. Very similar to the previous step of by part C. Okay, see if you can learn from it and try to do this. Okay, pause the video. Have a go at the question. When you're ready for the answer, you can press play. So the final answer, of course, is 0.79 and 50. Okay, depends on how you draw a line of best fit. Okay, you might have a slightly different answer to me, but in terms of working out, you can sort of learn from it. Okay, I will explain my working out and then see if you got it right. The main thing is about the gradient equals b and the y-intercept equals log a. So again, I start with r equals am to the power of b. I log on both sides, and I use multiplication law, log a plus log m to the power of b, then bring the b down, becomes b log m. Then I compare with my graph, log r is y, so y equals my log m is x. So therefore, I know my gradient is b and my y-intercept is log a. Unlike the previous one, this one is simpler. So not all question you have to do big chunk of rearranging and that kind of stuff. So this one is slightly simpler. You just have to match up which one is the m, which one's the c. So once I know the gradient is the value of b, what I do is I work a gradient using table values in here. So do the difference in y over difference in x. just be careful with negative, negative. So we just give you a plus. You should get 18 over 113. The gradient should be the same, okay? Should be the same. Unless you use different pairs of answers, pairs of numbers, obviously, but it shouldn't be too far off. And then the y-intercept, I look in the graph. If that's my 1.3, that's my 1.6, so I say this is 1.7. That's perfectly fine. So my log A equals 1.7, so A equals 10 to the power of 1.7. Using Bayes' law, I get 50. So these two are my answers, okay? Part D, okay, they tell you, okay, part D, use A equals 60 and B equals 0.75. So you throw away your part C answer, okay, you throw away your part C answer. Part D, basically, it means R equals AM to the power. So R equals AM to the power of B. Is that right? Yep, so you can write this formula, okay? Pause the video, okay, have a go at the question, see if you got the answer. When you get your answer, when you have the answer, you can press play. And here's the final answer. Okay, simply put m equals 80. Okay, and 2SF. All right. So let's move on. Okay, I know it's quite a long video, but in this video, it's quite important that you see different type of questions. I go through it. I hold your hand or hold your eyes step by step how we do that, so you can perform it in the exam. Okay, these are common exam questions. Example, and not the part A, part B, but more about part C. Anyway, example here. Example. Yeah, you can sit back and relax. The graph represents the growth of population of bacteria over T hours. The gradient, now I tell you the gradient at all I just said, okay? The gradient is 0.6, okay? With these type of questions, you can do highlight or underline the key numbers, and vertical axis is 0,2. You can imagine 0,2 is a y-intercept already. So scientists suggest the growth can be modeled by the equation P equals AB to the power of T, where A and B are constants to be found. Write an equation for the line. What line? This line, all right? This line. So how do you work out the equation of this line? Well, okay, so part A, okay? This line is a straight line, So it's a straight line, right? Straight line means y equals mx plus c, okay? So what do we have? Well, we have what p equals ab to the power of t. So same thing, we change the p equals ab to the power of t into log b and t. So remember, this is your y, and that's your x. So let's log on both sides. Oops, I shouldn't use orange. Let's use blue. So log on both sides. So log p equals log a b to power of t. So I'm going to skip the manipulation here. You've seen it so many times. Equals plus t log b. So once we know x and y, that's my y, that's my x. So this will be my m. Oops. And this will be my c. So what do I know? Well, what I know is gradient equals log b, which equals to 0.6 given by the question. And the y-intercept, y-inter equals to log a, which is 2. So from there, I know b equals to 10 to the power of 0.6 and a equals to 10 to the power of 2. 10 to the power of 0.6 is, oh, have I already done part A? Oh, actually, the answer part A is done. Sorry. I'll just write it. My answer part A is just log P equals to log A plus T log B. So part B of the answer is where I continue 10 to the power of 0.6, which is 3. They wanted to 3 SF, so 3.98. That's part B. And A, that's my part B. So A equals to 100. Okay. Right. So if I just write the equation again, so P equals to 100 times 3.98 to the power of T. Okay. Part C, interpret the meaning of the constant A in this model. Hopefully you do remember the value of A represents the initial amount. But in this question, you do have to give in context. So A represents the initial what? Population of bacteria. Can't spell. Okay, of bacteria. So that's the answer. Okay, A represents the initial population of bacteria. Simple. All right. So this time, your turn. Okay, practice question number 2. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, so here are the answers. Okay, question A, you log on both sides, you get log A plus T log B, And the final answer of part B is A equals 40, B equals 1.2. And C is the initial number of people felt sick in the beginning. And D is when N equals 9495. It's always overestimate because, okay, because they might have recovered after 30 days. Okay, so this model does not predict anyone who has recovered. So anyway, I'll go through part B. Okay, how do you work out part B? So if you got right, well done. That's the end of the chapter for you. Okay, if you got wrong, let's have a look at part B. Okay, first of all, again, you must know. Okay, judging by the graph, log n is your y, and and t is your x. What it means is this is your m, and that's your c value. So you will have to use this information to help you work out the value of a and b. So gradient. So I want to work a gradient. So I can use these 2 points to work a gradient. So difference in y minus 1.6 over difference in x. And you should get 0.095. So what it means is I know m is log b. So log b equals 0.095. Therefore, b equals 10 to the power of 0.095, which is 1.2 in two significant figures. And next, what about the value of a? Well, log a is a y-intercept. So y-intercept equals log a equals to 1.6. So a equals 10 to the power of 1.6, which I believe if you put in a calculator, you should get 40. Yep, 39.8. That's roughly 40. That's how you get part B, the answer. Okay. Part C, yep, initial. Part D, people felt sick after 30 days. So how do you work out part D? Well, now I know I can rewrite the equations as n equals ab to the power of t. So a is 40 times b to the power of t. When t equals 30, then n will equal to 40 times 1.t to the power of 30, which is 9495. Okay, given the reason why this might be an overestimate, I told you, I just said it. It's overestimate because, let me use blue. Because the model does not include people from recovering, people, English not my strongest suit, recovering from the illness. Or you can say or people may recover from the illness within 30 days. That's why it's an overestimate. Okay? Right, and that's the end of the chapter.